The internal clocks can have a period as low as 200 nanoseconds, or a period, or basically a rate of 5 megahertz. Basically, you put in a trigger that could be internal or external. That's followed by a delay in width. If the sum of the delay and width exceeds the interpulse period, the unit hence will ignore the incoming internal rep rate generator trigger or external trigger until it's fully timed out. Now, in order for the internal clock of the 565 to be operating, you have to disable the external trigger. If you enable the external trigger, it will say triggered. It needs an external trigger in order to operate. But in the disabled mode, the internal oscillator will operate properly. Now let's go to the external triggered mode, and here you can see I can select both the level of the trigger and the edge of the trigger, hundreds of millivolts up to several volts. I can also select the slope of the pulse from rising edge or falling edge. If your incoming trigger, especially if your incoming trigger has an active low polarity and you want to trigger off the leading edge of that incoming pulse, this is a means of selecting that falling edge as the trigger for your device mode. And if I turn the device once more, it says that I'm in the gated mode, and this gated mode tells you what level and what polarity will my signals be gated at. As you recall from the previous discussion, I can gate the individual channels selectively. So therefore channel A can be gated, channels B, C, D, E, F can be not gated. So that's something I can control. And that can vary from experiment to experiment. Now in the gated mode, I can decide whether it's gated, and if it is gated, I can select the level of the gate. I can also select whether it's active high or active low. These are the gate parameters for my box. Once more, remember that in order to have the internal clock operating, I need to have the external trigger in disabled. And the mode can be changed from various modes, from continuous, single cycle, burst, and duty cycle. In the continuous mode, what that means is I have my rep rate generator putting out continuous pulses. It's my internal rep rate generator whose period I have set previously. It's putting out pulses continuously. In the burst mode, the unit will only put out, in this case, 4 pulses into all the channels now. And after all the channels receive 4 pulses, they won't receive any more. And similarly, in the duty cycle mode, in this particular case, it'll put 3 pulses in, and after 2 pulses have elapsed, put another 3 pulses in. That's the duty cycle mode. And as you recall, in the case, we can also use this to have a divide by n feature, where I have 1 pulse on and n-1 pulses off, and basically now I've divided the incoming pulses by n. These incoming pulses can be either the continuous clocks that is generated by the internal oscillator in the unit whose period I have set, or it can be external trigger. Now I want to go back to the single cycle mode. If I select the mode to be single shot, this is the conventional digital delay operating function. In other words, for every external trigger I get in, I get I provide one pulse to all my channels. It's a one-for-one kind of operation. Let me talk a little bit about the jitter. External trigger coming in, 8 channels going out. The jitter between the 8 channels is synchronized to better than 1 nanosecond. If the channels are close together, the jitter will be on the order of 250 picoseconds. However, between the external trigger and the output channels themselves will be on the order of less than 5 nanoseconds RMS.